Hello, everyone. Welcome to videos on Chapter 3, Shape, Center, and Spread of Distributions. This one's going to be focused on shape and center. The next one's going to be more focused on spread of distributions. All right, so our first one here, you guys can see you've got one peak, so it's called unimodal. It's also considered bell shape, sort of like you've seen that description before, something like that. Also, if you draw a line through the center of it, both sides are mirror images. If you folded it over that vertical line, they would be a perfect match. So we would call this one unimodal, has one peak. And because when I draw the line, both halves are basically the same. They're mirror images of each other. We would call it symmetric. Now the next one also has one peak. So we'd call it unimodal, but it's not symmetric. If I drew a line here, for instance, and we folded these across that line, they would not be a good match. Also, just as I sort of traced it out with the curve there, if I trace this one with the curve, see this one sort of goes down and to the right. So this one, you've got the peak here, but it sort of trails off to the right. It goes, the right side stretches out. We refer to that as a tail, and that's called skewed right. So this one is unimodal because it has the one peak right here. But we would not call it symmetric. We've got this right side stretches out. It gets lower and lower and then stretches out to the right. So we would call that skewed right, whichever side the tail goes to. Tail goes to the right, skewed right. If the tail goes to the left, skewed left. Skewed right. So we can see here, we have two peaks. So not unimodal, but there's two of them, so bimodal. And again, if I were to draw a line through the center of this, and we folded those over, they would be a pretty good match. I mean, they're generally not going to be absolutely 100% perfect, but if we folded those two over, those are mirror images of each other. So we would also call this one symmetric. Okay. This one again, one peak comes down, and then we have another peak over here. So we would call this one bimodal also. But if I were to draw a line down the center of this one, it would not be a good match if they're not mirror images of each other. So we're not going to add the word symmetric to this one. This is just simply bimodal. Right? Now, these two are both examples of all the bars, all the histogram bins bars are roughly the same height. A little bit lower here, but they're all roughly the same height. It's not a dramatic difference. This one's even more so roughly the same height. And when you have that scenario, what's going on here? Okay. And so when you have that, where your peaks, so your bars are roughly the same height, it's kind of like in the Army, everybody wears the same clothing, and you call that a uniform. So these are uniform distributions, uniform histograms. And so they're roughly the same height, right? And so we see again on this one, if we trace it out, up, right, and you can see this tail stretches way to the left, and this one, if we sketch it in, this one, the tail goes far to the right. So again, another example of skewed. This one would be skewed left and skewed right. A little bit more with shape. So when we go to this one here, we notice just kind of random. We sort of have a peak here and we have a peak here. But the key thing I want to talk about here is you've got a gap in between. Right? So you've got sort of a gap right here. And then you've got a big cluster of values here. And then you've got a big cluster here. All right. So in this one, though, where you've got this gap, you've got a whole bunch of data right here, and then you've got this gap, and then you have very few, just a couple of them out here, right? In this case, because we have just a couple of data values far removed from the rest of them, whereas here, there's a whole bunch of data values here, a gap, and a whole bunch of data values, we would not say this, but over here, we've got outliers, right? A couple of data points that are far removed from the rest of them. Right? So in both cases, we would say we have gaps. Right? But because we've got just a couple of data values far removed from the rest of them, we would say that we have outliers over here as well. We're going to get a little bit more technical about what is considered an outlier and what's not, but that's a few slides down the road. Right? And real quick, we're going to run through mean and median. When you talk about the center of a distribution, we just did shape of a distribution. We're now going to do center of a distribution. There's two ways of describing it, mean or median. Mean, you guys have been doing this for quite a while, just the average. And median, it's the middle, and I put middle name, that should be middle number. Fix that later. The middle number when the data set is ordered from least to greatest. So we're going to do a couple of examples. So here I have some data. I've created a histogram. And you can see it's fairly symmetric. There's a little gap there, but it's not like this data is really far from. It's only 1 unit away from. And what I want you to notice is, you've got sort of a symmetric. Let me sketch again. If we sketch it, that's roughly symmetric. If I drew a line down the middle, we'd fold it, it'd be a pretty good match. So what I want you to notice is that when it's symmetric data, the mean and the median both do a pretty good job. Usually when it's symmetric, we're going to report the mean. Okay, so you usually use the mean for symmetric data, symmetric distributions. I don't know what caused that. But they both do a pretty good job when it's symmetric data. But again, for symmetric data, the preferred, because of, it's not perfectly symmetric, the mean's going to do a better job. So let's take a look at some data that is not quite so symmetric. All right. So you guys can see over here, we've got a little gap, but that's not much. It's only 1 unit away. Here's the gap that we're talking about more. So this one, we've got a gap, and it looks like we've got an outlier. So I've got the same data that I had before, except I added the 19 in there, which now creates gaps and an outlier. And what I want you to notice is that when we did that, the median did not change. Okay? The mean did. So what happens when there are gaps, or especially outliers, this is probably true even with skewed, there we go, skewed distributions, all right? So with skewed distributions and outliers, the mean is going to stretch in the direction of the outliers. We had outliers on the high end, so the mean went up. If we had outliers on the low end, the mean would go down. If this was, and it sort of is, if it's skewed right, these large numbers are going to pull up the mean. If it's skewed left, the small numbers are going to pull down the mean. So what we prefer to use is, because the median is not affected as much and we're still looking for the center, sort of like the middle, the typical number, the average when we talk about the center, is when you have outliers or skewed distributions, it is best to report the median. All right, so that takes care of shape and center.